Tell me, when did you buy the car?
We bought it in 1967, probably around February 1967. It's a 1965 289 high performance, 4-speed, 271 horse, 289. It's a 2002 Ford Racing short block. It's 347 cubic inches, has 10-to-1 compression ratio, has a competition cams hydraulic roller camshaft, the biggest hydraulic roller you can put in one and still maintain anything on the street. I mean, there's no point in going any bigger than that cam unless you go to a solid roller camshaft. It has airflow research, aluminum heads, same size valves as the 202 intakes on a Chevy. So it breathes very well. And heads are the secret, one of the secrets anyway, to developing a lot of power and dissipating heat. So you can run a little bit more compression with aluminum heads because they dissipate the heat better, and you won't get pre-ignition quite so readily. The heads have a complete competition cams roller rocker system on there. The rockers do not flex at high RPM. They maintain their integrity, and it's a little easier on the valve train, the push rods and the valves themselves. Nothing flexes, so it runs a lot smoother and quieter. This one is a Holley HP 750 double pump, and it's strictly a racing carburetor, this particular one. It has no choke system. It has different power valves, it has different accelerator pumps, it has four-way mechanical linkage so that all butterflies open at the same time.
Instead of a primary and a secondary?
Well, it has primary and secondary, they just all open equally. My belief is that they are equal in size. The primaries aren't smaller and the secondaries are not larger, everything is the same. It's a fuel pressure regulator. It's a higher voltage coil than a stock coil, and it recovers faster than a stock coil, so it can send out a larger pulse of electricity to the distributor. It can send it faster, so it can rev higher and sustain higher rev on the engine. That is part of a remote oil filter system, and it's just I could run a larger oil filter and put it in an easier position. Actually, I was going to use 2 oil filters, but I didn't.
And we went electric fan?
Well, space. Takes up less space, and it takes less horsepower. It doesn't rob the engine of horsepower, it uses electrical power to run it. Yeah, that's called a spray bar. And the nitrous is sprayed underneath the carburetor, between the carburetor and the intake manifold. It's sprayed directly down. And then there's also a solenoid for gasoline to go in there, and it also sprays below the carburetor. It does not go through the carburetor when you're running the nitrous. The extra gas gets put through a spray bar, just the same as the nitrous oxide, because you need a lot more gas to work in conjunction with the nitrous. This is a 347 cubic inch.
And when you say it's a stroker motor, what does that mean?
Well, basically it was a 302, and then they changed the stroke, put a different stroke crankshaft, and they bore it. So it's got an overbore and a different stroke. And the other thing that's different in it is the rod length. The rods are a different length than a 302. And it gives you quite a different ratio, rod length ratio. So it's got a lot more, very torquey motor. That spring has to do with an accelerator pump, and when you work the linkage, I'll do that for you. The accelerator pump is actuated and it spits gasoline into the carburetor, but you don't want it to be lazy coming back. Once you release the throttle, you want the accelerator pump to come back real quickly too. Let me just go ahead and work that for you. See how it goes down, and then it comes back. This is crankcase pressure. That when you rev the engine real high, you get some blow by the piston rings. It creates pressure in the crankcase, and the goal here is to release that pressure through this line and recirculate it back into the intake manifold below the carburetor, and to have that pressure, give it a place to go, and to also burn it so that you're not just slamming oil residue and crankcase pressure out on the street. That's the name of this particular intake manifold. It's made by Edelbrock. That it allows air to go completely underneath the manifold and exit the back of the engine. Where lots of different manifolds don't allow air to go under them, so they retain more heat. The goal is to keep the gasoline charge as cool as possible, and then you can get more of that into the cylinders and it runs stronger.
Right. Is this a dual plenum or just a straight throat?
This is a dual plenum intake manifold. This is a MSD billet distributor. These are hooker headers, and they're equal length. They do a lot of changing around once you get underneath the car. I ended up getting 1 5/8 just for ease of installation. The collector goes right into 3-inch aluminum coated exhaust pipe, and it goes to Flowmaster mufflers that are 3-inch inlet and 3-inch outlet, and that goes all the way to the rear of the car and over the rear end and then out the back of the car, just like standard exhaust pipes. Yeah, those are solid engine mounts. The advantage of running a deeper sump oil pan is that you can run a larger capacity, bigger amount of oil, and that helps with engine cooling, and it also means that you don't have to run the oil quite so close to the crankshaft. If the crankshaft hits the oil, then you get a condition called foaming, and you can actually damage your engine because it's not getting a solid shot of oil through the oil pump if it foams. So the idea is keep the oil away from the crankshaft, run a large amount. You always have a good supply of oil that way, and you don't run into a foaming problem. And also the oil pickup is in that deepest part of the sump, so when you accelerate really hard, the oil does not go to the rear of the pan and uncover the oil pump pickup. The brakes are by Aerospace, and the rotors, I believe, are 12-inch, and the ladder bars are adjustable. They are Caltrax, and they're on just about every single car that is a super stock record holder in the NHRA. They are really a well-proven, well-adjustable bar for any track condition. The rear end is a Ford 9-inch rear end housing. It's been narrowed 1.5 inches on each side, so it's a total of 3 inches narrower than a standard Ford 9-inch rear end. It has the big axle bearings in it, in the housing. It has a 411 Mark Williams spool, so there's no differential. Both axles turn the same speed all the time. It has 35 spline Mark Williams axles, heavy-duty U-joints, heavy-duty drive shaft. Everything is built for racing. It's a steel shaft, not an aluminum shaft. The rear end housing itself has been completely braced so it won't bend or flex under acceleration. And the degree of the pinion angle has been set. Flowmaster 3-inch mufflers, 3-inch inlet and 3-inch outlet, so that there's minimal back pressure on the exhaust system, and that allows the engine to breathe a lot better. If it can get air in and pump the air out, essentially an engine is just an air pump. So the faster you can move the air in and out, the more horsepower you're going to make. Flowmaster mufflers are very quiet until you're at full throttle, then they do make more noise.
These taillights weren't.
Those are stock. LED bulbs in there, so they're much brighter than the stock ones. That's electrical for the entire car. If I open the trunk, I'll show you how it works. That's a Harwood plastic 15-gallon fuel cell. It's foam filled, and the big aluminum line coming off the top and going towards the front of the car is a vent. And it also, at one point in there, has a backflow valve so that if the car's upside down, it cannot still spill gas. The reason I chose the Harwood is they're one of the most famous out there and been involved in a lot of crashes, and they don't rupture and spill gas. It is obviously it's strapped in place. That's a steel floor in the trunk now. That used to be a gas tank was the trunk of the Mustang in prior times. This is a solid steel floor. There are two fuel lines leading from the fuel cell. They both go to a Fram racing fuel filter, and they each go to a Mallory 115 gallon per hour fuel pump. The one closest to the battery is the one that supplies the car with fuel all the time. It's always running off of that pump. The second fuel pump is the one that supplies the extra supply of gasoline to the engine when the nitrous oxide is turned on. So it takes a dual fuel system in order to run it with the nitrous oxide. The battery has been removed from the front and put in the trunk just to put more weight over the back and less weight on the front. There is a ignition. It's not just an ignition, it's a total electrical cutoff switch on the battery in case that you're leaking or there's a problem with the car and the driver's unaware of it and the car's on the starting line at a drag strip. Somebody can come up behind it and just push the button and kill the car and not let the guy take off and have a problem down track and maybe crash. The tank is filled with foam, and that helps to keep it from rupturing in the case that it is hit or turns over, and it also keeps the fuel from sloshing real badly back and forth under hard acceleration or deceleration or cornering. The entire trunk has been cleaned and then spray painted with Zolatone. The roll bar, it's an 8-point Alston cage, and you can see where the plates are welded to the flooring of the car. And farther forward at the back of the rear seat is a steel firewall. And that's designed to keep gasoline from going forward into the passenger compartment should the tank be ruptured for some reason. Underneath that package tray is another steel firewall, so that there is no possible way for gasoline to penetrate into the passenger compartment in case of a rollover. And that's the main thing, is keep fire away from the driver if you can, give him a chance to get out. The blue bottle that says NOS on it is a nitrous oxide system. It provides nitrous oxide when that valve is opened at the top of the tank. Then that charges a line all the way up to the carburetor. And that line is actuated by an electrical switch on the throttle of the car. When the throttle is pushed to wide open position and the electrical system for the nitrous oxide is energized, then it will open the solenoid switch and allow the nitrous to go underneath the carburetor and enter the engine. And also it allows the gasoline that is connected with the nitrous oxide system to go into the engine too, and it probably can give in the vicinity of another 200 horsepower to the car. These are 5-point shoulder harness lap belt with a Subway strap on it. They're 3-inch wide, and they're made by Chute Metal Products in Chatsworth, California.